Hey guys, T-Bones here, coming at you with your work for the day, lesson 80. Okay, here we have prime and composite numbers. Okay, we'll talk a little bit about what those are. We have practiced listing the factors of whole numbers. Some whole numbers have many factors. Okay, other whole numbers have only a few. So when we talk about this, the factors, this was when you had, say, 12. You're trying to figure out what numbers multiplied together equal 12. Well, you have 1 and 12. You have 2 and 6. You have 3 and 4. And then now you've met in the middle, and so there's no other numbers, right? There's no number in between 3 and 4, so you're done. Those are all the factors, okay? Those are the factors of a number. Now, some numbers, however, say like the number 13, done. End of list. 2 does not go into 13. 4 does not go into 13. 5 does not go into 13. 6 doesn't go into 13. 7 doesn't go into 13. 8 doesn't go into 13. 9 doesn't go into 13. 10, 11, 12, none of those go in evenly. The only number that goes in evenly is 1. Okay? We call any number like this a prime number. Okay? Because the only number that goes into it is 1. There can only be 1. Okay? So this little Optimus Prime boy over here, 13, joins an elite club. Now, of this elite club, you can figure out, let me ask you, I guess, why do you think there can never be a positive prime number with the exception of 2? 2 is the only number that's positive that is not that is prime. All other positive numbers are not prime. Why do you think that is? Okay. Well, by definition, a number that is even can be divided by 2. So, all prime numbers can be, or all non-prime numbers can be divided by 2, which means that if they can be divided by 2, they can be divided by more numbers than just 1 and 13. Right? So if I look at 14, which is prime, or sorry, which is even, 14 can be divided by 2 and 7. Okay, so obviously it's not prime because it's got another option. Okay, over here, 2 is the only even number that's prime, and that's because, yes, 2 goes into 2 evenly, but it only does it once, and so 1, 2, that's the only one is prime. That's our definition of prime. Okay. We call any number that can be multiplied by something else or broken into other parts, we call these composite numbers. Okay. So they also go through some more prime numbers over here. We're still always looking for more prime numbers. There's a whole thing about it, but it's big in the math world. It's a fun little puzzle. So every number in the shaded part, okay, all of these numbers in this multiplication table, all of them are composite numbers, right? Because each one of these numbers can be multiplied by multiple things, right? 88 is 8 and 11. 80 is 10 and 8. Okay? It can be multiple things too. There's other numbers that go into 80, like 5 and 20. Right? No, 5 and 16. Yeah, 16 and 5 go in is 80. So there's more. Oh, sorry. Just because a number is on here doesn't mean that it's only composite, but any number that's shaded here is definitely composite. Okay. Array of rectangles. We can see the 3 different arrays for the numbers. 12 is a composite number, which is demonstrated by the fact that we can use different pairs or factors to form arrays. Okay. So all 3 of those are the same or same number, same 12. Okay. However, 1 through 11, there's no way to do it evenly, right? So we're gonna skip the activity. I'll do the lesson practice. Well, we're gonna skip A on the lesson practice. Actually, I guess you're skipping all of the lesson practice because it all involves the arrays. So don't do that. On the rest, the written practice, just do 1 through 10. 1 through 10 all. All right, that's it, my dudes. Have a good one.